vast universe, Earth is the only planet we know to have life. Life on Earth exhibits diversity and creativity here. So how did the life first emerge on Earth? Earth's early atmosphere lacked oxygen and consisted mainly of ammonia, methane, hydrogen, and water vapor. This environment provided the necessary chemical ingredients for the origin of early life. At the same time, the enormous energy generated by the impact of some asteroids and comets on Earth vaporized the oceans, possibly bringing the first water and organic matter to Earth. Over time, the Earth gradually cooled, forming stable land and oceans. Under such conditions, organic molecules began to accumulate in seawater, creating the conditions for the origin of life. The RNA hypothesis suggests that the first forms of life may have been RNA molecules, not DNA. RNA and DNA are nucleic acids that store and transmit genetic information, but unlike DNA, RNA also has a catalytic activity that can facilitate chemical reactions, which is similar to the function of enzymes. Therefore, RNA can act as both genetic material and biochemical reactions, which means that RNA may carry out the basic functions of living organisms in the absence of proteins and DNA. However, the RNA world hypothesis also faces some challenges. For example, RNA molecules are relatively unstable and easily broken down by water, which is a problem for a series of RNA as the origin of life. Deep water vents, also known as black chimneys, are vents of hot water in areas of the ocean floor where plates are tearing apart. The chemical environment of these hot spring areas is unique. Organic molecules such as methane, hydrogen, sulfide are abundant here, providing abundant food and energy for life. Considering that the early Earth may have had a large amount of volcanic activity and undersea hot springs, and the unique environment these hot springs provided for life, the deep-sea hot spring hypothesis becomes a strong candidate for the origin of life. However, this hypothesis still faces challenges. For example, how do you ensure that complex molecules like DNA, RNA, and proteins are stable at the high temperatures of hot springs? Another theory about the origin of life is the Fourier theory. The Fourier theory is based on the observation that there is a large amount of organic matter in space. For example, some meteorites have been found to contain amino acids, the building blocks of proteins. This means that the right conditions could exist elsewhere in the universe for the building blocks of life to form. But even if the Fourier theory is correct, it only takes the question to a new level. How did life originate on other celestial bodies? The origin of life on Earth is something humans have been trying to figure out. In the future, we need more research and more advanced technology to further explore the origin of life. With the development technology, we may be able to gain a deeper understanding of the early Earth's environment and how life formed in it. The origin and evolution of life is an ongoing process, and we, as part of that process, have a responsibility and obligation to explore and understand it.